Welcome to my YouTube channel Modi Mechanical Engineering Tutorials. So in this video I would like to explain in detail on MCQs on grinding machines, or you can say basically onto the grinding wheel. So this is our session number 3. So this is a special preparation for all the government examinations, GAT examinations, UPSC kind of examinations. So first of all, subscribe my channel, and now we will start with the question number 1. Which of the following is a surface finishing operations? Option A, drilling. Option B, honing. Option C, milling. And option D, turning. So basically drilling, that will be used to make a hole. So for making a hole, drilling is being used. Then honing. So generally honing, it will be considering as a surface finishing processes. Surface finishing. C, milling. So generally it will be making a flat surfaces onto the metal cutting operations. And option D, turning. So generally turning is being used to make a cylindrical surface or work onto the cylindrical surfaces. So now just we focusing over here for honing. So basically honing, it will be used to make a internal surface finishing. So basically for finishing a cylindrical kind of job, so you can use the honing process. So just you can see such kind of component is there, and if you want to finish these surfaces, so just you can insert the honing tool, and on that honing tools the abrasive sticks is being mounted with the application of spring force. So according to their spring force, it will be towards both the sides. So it will be fixed onto that internal surface, and this tool is being rotated as well as reciprocate. So you can easily make the surface finish. So the question is, which of the following is a surface finishing operations? So that will be, we already discussing option B, honing. The next question. Grinding is best suited to machining of option A, soft materials. Option B, very hard materials. Option C, both A and B, or you can say both soft materials and very hard materials, and none of the above. So basically grinding, it will be best suited for the very hard materials. So that will be easily you can converting into desired shape and size. In case of the soft materials, so that soft materials, it will be deposited onto the grinding wheel. So that will be having the difficulties to converting into the finished products. So basically grinding is best suited to machining for a very hard materials. So that hard materials, or you can say brittle materials, easily converting into the powder form, and you can easily removing the materials. So the option B, very hard materials. The next question. Stainless steel is very difficult to grind due to its option A, toughness. Option B, ability to work harden. Option C, both A and B, or you can say both toughness and ability to work harden. And option D, none of the above. So basically stainless steel, that will be the category of the toughness as well as ability to work harden. So stainless steel, that will be having such kind of characteristics, so that will be difficult to grind. So that would be the right answer is both toughness and ability to work harden. So option C, both A and B. The next question. Which of the following properties changes due to the grinding? So option A, mechanical properties. Option B, physical properties. option C chemical properties, and option D all of the above. So basically on each and every metal cutting operations, or you can say conventional metal cutting processes, all the materials it will be changes its characteristics, or you can say properties. So the properties like mechanical properties, physical properties, as well as chemical properties. So here that will be the question is regarding to the which of the following property changes due to the grinding. So grinding is considering as a conventional machining process. So all the properties is being changed. So the option D all of the above, that will be the right answer. Then next question. Following is a type of centerless grinding. Option A through feed grinding, option B in feed grinding, option C internal centerless grinding, and option D all of the above. So basically in the centerless grinding process, generally that will be the through feed grinding process is being also used, in feed grinding process is also being used, and internal centerless grinding is being also used. So that will be generally depends upon the which kind of shape and size and which kind of working space, or you can say working surface is available. According to that we have to select the different kind of centerless grinding process. So if you want to learn in details of that particularly centerless grinding process, so you will find a link in my description box. So in that case it will be well explained about the centerless grinding process with its all types. So these all A, B and C, it will be types of centerless grinding process. So the option D all of the above. Then next question. Most cylindrical grinding machines include A, which to allow the forming of tapered piece. Option A grinding dog, option B swivel, option C center driver, and option D none of the above. So basically for cylindrical grinding machines it includes a swivel to allow the forming a tapered piece. So if you want to make a tapered piece onto the cylindrical grinding machines, so it must be swivel. So you have to swivel that, then you can easily forming of tapered piece. So the option B, that will be the right answer for this question. The next question. In which of the grinding methods rate of material removal is higher? Option A surface grinder, option B cylindrical grinding, option C creep feed grinding process, and option D all of the above. So according to the first option, surface grinding. So generally surface grinding process is making a smooth surface. So in that case of the surface grinding, that will be the less amount of metal removal rate. In case of the cylindrical grinding, that will be the moderate kind of metal removal rate. But in case of the creep feed grinding process, so by application of pressure you will performing the grinding operations. So in that case it will be the higher amount of metal removal rate, and all of the above it will be not possible. So according to this creep feed grinding process, that will be having a higher metal removal rate. So answer C. Then next question. In centerless grinding, workpiece is supported by option A centers, option B chucks, option C work rest, and option D all of the above. So for detailed study in centerless grinding process, you will find a link in my description box. So basically in case of the centerless grinding process, it will be supported by work rest. So option C, that will be the right answer. So just you can see, that will be our grinding wheel and that will be our regulating wheel, and this is our workpiece. So this is called to be a work rest. So generally workpiece is supported by at your work rest in case of the centerless grinding process. Then we will discussing with the next question. In cylindrical grinders, how many centers hold the workpiece? Option A 1, option B 2, option C 3, and option D 4. So basically in construction and working of the cylindrical grinders, if you want to learn in details, so the link is given in my description box. So basically two types of centers hold the workpiece. So the right answer is B 2. Then next question. Grinding is commonly used on option A aluminum, option B brass, option C plastic, and option D cast iron. So in earlier some of the videos I already explained that basically grinding process is best suitable for working onto the hard materials, or you can say brittle materials. So here that will be the option A, that will be the aluminum, so that will be considering as a ductile materials. Brass, which is also considering as a ductile materials. Plastic, which is having a good plasticity, so it will be having a difficulties. And cast iron, so that will be a brittle materials. So grinding process, that will be generally onto the hard materials, or you can say brittle materials. So the right answer is option B, cast iron. So if you like this, then subscribe and share Modi Mechanical Engineering tutorials. Thank you so much and keep watching.